Hello and welcome back. So in the previous video, we saw about the numerical features, basic understanding, linear versus non-linear equations. So here we are going to understand that what are the key points which we must need to remember when we are working with these features, linear versus non-linear. Okay. So the first thing is that let me again revise the concept of linear versus non-linear. So this is the simple example. Suppose we have a data set with two features, X and Y. X could be something like, uh, the amount of fertilizer, or Y could be the amount of, or you can say the quantity of the harvest that you are getting, right? So anything could be there. So there could be a simple linear regression model like y is equal to mx plus c. So wherever there is this kind of equation, y is equal to mx plus c, then in that case, it is known as a linear equation. And in case of a polynomial, we have the powers introduced to the independent variable. So x is an independent variable, which means like it can take any value. But yeah, y is a variable whose value is dependent on the value of x. So y is a dependent variable. So these dependent variables are basically the values that we want to predict, right? We want to, whenever we are going to create a prediction model, then in that case we are going to just calculate the value of y, right? We will be calculating the value of y whenever we will be creating a prediction model. So the second model, which is the squared term, ax square plus bx plus c, it can capture a parabolic curve. We have studied in the previous video as well that whenever we are working with a squared term, then it will create a parabolic curve, right? So the basic mathematics behind the parabolic, hyperbolic, all these curves, I'm not going to tell you in this video. Maybe I will cover these things in the next video, like how to see and how to find out that what curve belongs to degree 2 or degree 3. There is a basic mathematics involved behind that, right? So that I'm going to tell you in the next video, or maybe after discussing the example for the regression model. I After that, before starting a new topic, I will show you that how you can decide that, after just looking into the curve, how you can decide that yes, this is a curve for the polynomial of degree 2, 3, 4, whatever, right? So that will be really interesting and really important to know for you. Okay, so the second model, it will capture a parabolic curve which is more flexible than a straight line, obviously more flexible than a straight line, and it will be able to cover more points in the graph, which have the graph which has been resulted after plotting it against the data set that you have. There are few key points that you must need to remember. First thing is the degree of the polynomial. The highest power of the polynomial determines its complexity, right? So suppose you have the power of 4, then in that case, that power of 4 defines the complexity. I mean, how complex is the curve? How complex the data is? Create a prediction model, or to develop a prediction model, right? You can say the machine learning model. Whenever you are creating a machine learning model for predicting something, then in that case, how complex your data is, how complex is it for your data to help preparing a machine learning model, that is decided by the degree of the polynomial, right? Higher degrees can fit more complex curves, but also increases the risk of overfitting. What is overfitting? Overfitting means you are, just fitting too much, right? In that case, what will happen that it will not be able to just predict at few instances, it may not be able to predict the values correctly, right? If you are overfitting it, because maybe some of the points could be there which are in the real life, maybe they could come which are not as per your data set against which you have trained your model. So in that case, if you are overfitting it, then in that case it will be giving you wrong results, maybe deviated results, right? So this also causes the increase of the risk of overfitting, right? Overfitting, I mean, you should not do kind of overfitting. You should not fit exactly, right? You should fit in such a manner that this is just like looking like it is covering most of the points, or it is going through most of the points of the curve, right? And also, the second thing is that whenever you are adding a power to your equation, or that you how you add, I mean, if you have a feature, suppose you have a feature x, any name of the feature is x, and when you are increasing the power, then you are doing something like ax square, right? Then bx plus c. So from the existing feature only, from the existing feature which was the x, you are creating x square, right? So having the existing feature and again doing the creating a new feature which is basically containing the value which is having the square of the original feature, then in that case this will be increasing the number of features in your data set. And whenever the number of features are increasing, then obviously you are going to be involved in the feature engineering that we are studying. So in feature engineering means you have to do kind of kind of for the fitting, you have to do extra work, right? You may need to remove some of the variables. You need to find out how many variables are outliers, how many features or the values against a feature are outliers, right? So all those things will keep involved, start involving, right? So the feature engineering will become complex, right? Or you may need to, or you will open a scope for the feature engineering, right? Something like that we have to say. And then model complexity. Obviously, the first point was that higher power of the highest power of the polynomial decides whether it is complex or how much complex it is basically, right? Whether it's complex or it's simple or it can be fit into a linear regression. All those things are decided by the power of the polynomial or the degree of the polynomial, right? So by understanding the polynomial transformation, you can build more powerful and flexible machine learning models, but you must need to avoid the overfitting. So how we avoid the overfitting, all those things we are going to cover in the coming videos. But yeah, as of now, you can understand that what are the linear and non-linear regression and why we need to use them. Okay. So in the next video, I'm going to show you a kind of example in the Python code where we are going to fit the curve in our data, right? And then we will see that which curve is fitting best, right? There will be a uh, polynomial regression kind of example, right? So after that, we will see that how we can determine whether a curve is relating to a degree 3 polynomial or degree 4 polynomial or degree 2 polynomial, right? So finding out that is really important, because based on the graphs plotted, you will be able to see the you will be able to decide what should be the power or when you should stop, right? Because without visualizing it, you will not be able to decide it properly. And after visualization, you will be able to see like at how many points it is intersecting at a particular axis, so that you can decide that it's a power 2, power 3, power 4, or whatever power polynomial is it, right? So to decide the degree of polynomial, you must need to be able to recognize the curve, that what kind of curve is it, right? So stay tuned. In the next video, we are going to see an example, and after that, we will discuss a few more things related to polynomials. Thank you. Have a nice day, and bye bye.